this lesson is over algebra representation involving more about equations. So let's look at our number routine. How do you know? So from what I could tell, this is a table. It's about jars cost. 2 jars cost $11. 8 jars cost $44. 12 jars cost $66. Write an expression using the variable g. And then what is the independent label? So 2 jars cost $11. 8 jars cost $44. What if I buy 1 jar? How much would 1 jar cost me? If 2 costs $11, 1 jar would be $5.50. This is half of it. How do you turn 2 jars to 1 jar? 5 by 2. 11 divided by 2 is $5.50. So write an expression. That means I am multiplying the number of jars by 5.50 or $5.50. So my expression would be $5.50 times J, or $5.50 per jar. What is the independent label? So independent. If you remember from science class, x-axis, this is the y-axis. This is y next because and manipulate. You can manipulate the independent, and because of that, the independent will respond to it. So the independent is the x. So this is the x-axis, and this is the y-axis. Jars are the independent label. This would act as jars, and the cost depends on how many jars you buy or sell. So what is an equation? An equation states that two things are equal. We'll have an equal sign like this. For example, x plus 2 is equal to 6. This is equal to that. If you put them on a balance scale, they'll both be balanced. The left side is equal to the right side. That equation says 2 on the left, 2 is equal to 2 on the right, 6. So a statement is like, so an equation is like plus equals that. So in this activity, during class, you will be given these examples. You will separate them into expression or equation. There are 6 expressions for 6 equations. So let's see. Let's go back. Equation has an equal sign like this. So let me circle the equation. Circle the equation. So this is the equation. This must be the equation because this equals that. This must be equation. This must be equation. There are 2 more. The number of shoes is 2 times the number of students. The number of shoes is, wait, 5 plus 4 is 9. 5 plus 4 is 9. Is means equal. This number of shoes is, this is an equation. Keep going down. Sum of angles A and B means you add A and B is 180. This must be an equation. So those are the 6 equations. And that's the 1, 2, 3, 4, 5, 6. So in today's activity, we are looking at algebra relationship. In figure 1, there are 3 total tiles. So there is 1 group of 3 tiles. That's my verbal description. In figure 2, I see 6 tiles. So there are 2 groups of 3 tiles. 1 group, 2 groups. There are 9 total tiles. So there are 3 groups of 3 tiles. Number 4, oh, I have to draw it now. So let's see. 1 group, 2 group of 3 tiles, 3 groups of 3 tiles, four groups of four tiles. So four groups of three tiles. And number five, there's one group of three tiles, two groups of three tiles, three groups of three tiles, four groups of three tiles, five groups of three tiles. There are 15, five groups of three tiles. So complete the table inside the order to write the equation with the pattern above. Go back up. Figure one has three tiles. Figure two has six tiles. Figure three has 9. Figure 4 has 12. Figure 5 has 15. So what relationship? Do you notice a relationship about this? If I know the figure number, the total number of tiles, I would have to multiply by 3. So the equation, so first of all, the expression is 3 times x. So an equation is this equals that. We are multiplying this equal that. So I already have that. I'm multiplying the figure number by 3. So to find the total number of tiles, I have to multiply the figure number by 3. So the equation would be y is equal to 3. So y stands for the total number of tiles is equal to the figure number. You multiply by 3 to get that. But what do you notice in the equation? Is it additive or multiplicative? Add the multiply to come up with that. So that's the relationship between the figure number and the total number of tiles. What do you notice about the fraction y over x? Let's see. Y is 3, x is 1. Y is 3, so 6, x is 2. Y is 9, x is 3. Y is 12, x is 4. Y is 15, x is 5. This will equal 3. If I simplify, equals 3, equals 3, equals 3, equals 3. So what do you know about this? Well, to find the relationship between the figure number and the number of tiles, I have to multiply by 3. So if you look at the back fraction, y divided by x, you get 3, 3, 3. So that's what I noticed. What I noticed is to find a relationship, you could do y divided by x. And pretend there is a figure 0. Figure 0. Figure 0. What would it be? If you have figure 0, you won't have anything on. So there are 0 groups of 3 tiles. 0 groups of 3 tiles is 0. So following this pattern, always look at the table. 0, 0. Next one. So in pattern B, we have 3 squares shaded and 1. So there are 4 total tiles. 1 tile and a group of 3 tiles. Oh, so the group of 3 tiles is shaded and you have 1 tile. There are how many tiles here? 1, 2, 3, 4, 5 tiles. So in my verbal description, there are 2 tiles, because you have tiles, and a group of 3 tiles. That's figure 3. Oh, and draw it. So this is the original shape. 1, 2, 3. There are 6 tiles. Oh, I have 6 tiles. Those 3 tiles. There are 3 tiles here, and you start with a group of 3 tiles. There are how many? 3, 4, 5, 6, 7 total tiles. My verbal description is there are 4 tiles and a group of 3 tiles. And figure 5, so I know we start with a group of 3 tiles. Shaded. 1, 2, 3, 4, 5. So that's 8. So there are 5 tiles and a group of 3 tiles. So complete the table inside a bulleted order and write the equation. So in figure 1, we have 4 tiles. Figure 2, we have 5 total tiles. 6, 7, 8. What's the relationship? What do I have to, what's the relationship between the figure number and the total number of tiles? We're adding 3. So we add 3 to x, which is the figure number. But to find the total number of tile, which is y, you have to equal or add 3 to the figure number. So the equation is y equal x plus 3, where y is the total number of tiles. To find it, you have to add 3 to the figure number. So what do you notice about the relationship is additive. So now let's go at this. Y divided, so 4 divided by 1, 5 divided by 2, 6 divided by 3, and I'll right here. 4 divided by 1 is 4, 5 divided by 2 is 3.5, 6 divided by 3 is 2. What do you notice? They're all different numbers. Oh, so when you do, is it multiplicative? Have you noticed, let's go back here. When it's multiplicative, when you do y divided by x, they're all the same number. But when it's additive, the numbers are all different. Pretend that there is a figure 0. Go back to our drawing. If you have figure 0, you'll have 0 tile and a group of 3 tiles. So answer would be 3. And let's see that relationship work. Figure number 0 plus 3 is, and that is today. So that is today's activity. And this last activity we're going to do in class is you're going to be given a table such as 6, 8, 12, 15. This would be like these 8, 10, 14, 17. Can you find a relationship here? How do you turn 6 to 8? Oh, x, y. How do you turn 6 to 8, 8 to 10, 12 to 14, 15 to 17? We are adding, or is it multiplying? Is it additive or multiplicative? It's multiplicative. What are we multiplying 6 by 8? Sure. Additive. Plus 2, 8, 10, plus 2, 12, plus 2. So you're adding 2 to x input, and you get the output. Find the output, you have to add 2 to the input, y equals. But what if the relationship is here? This is 3, 5, 8, 10, plus 2, 33, 55, 88, 10. What's the relationship from x to y? Is it additive or multiplicative? It's multiplicative because you multiply by 11. 3 times 11 is 33. 5 times 11 is 55. So we're multiplying 11 by the input, x. Find the output, y equals 11x. All right.